We are working on the bit by bit project from the YByte Python curriculum available at www.ybyte.in. Previously, we looked at binary numbers and counting with binary numbers. We also saw how to convert, say, between decimal numbers and binary numbers. Now, having done that background, it's time for us to move forward and look at what bitwise operators really mean. Well, bitwise operators are Python operators that operate on numbers, literally bit by bit, um, and hence the name. Now, like we discussed, Python supports bitwise operators, even though it is a high level language. Very often we don't think in this ways, but then there are situations where these become useful. For example, where the logical unit of thinking, as I said, is a single bit. We will see it quite vividly when we look at the LED project that we have to build through this. In this video, however, let's take a big picture view of bitwise operators. Let's look at what the different operators are, where do they fit in, and so on, before we start taking a deeper dive. As we saw, Python has, 7 types of operators: arithmetic, assignment, comparison, logical, identity, membership, and bitwise. Now, through our journey in programming, we have extensively worked on, let's say, 1 through 6. So it's only logical that, we complete the spectrum by looking at bitwise operators, and that's what we're obviously doing in this project. Um, as before, operators, work with variables and values. And since bitwise operators are also operators, they also work on values and variables. Specifically, they work on numbers. And just like, any other operator, they may create a new result, they may modify content of an operand, and so on and so forth, right? So for example, let's say I had A equals to 10, so that's an assignment operator. B equals to 3, that's again assignment. I'm saying C is equal to A plus B, so assignment, and followed by the arithmetic operator. We know that C would be 13 at the end of this code. So that's a new variable created, C with 13. Take another example, B is 10, for instance. If I do B is minus B, well, this is what is called a unary operator, so just takes one operand. But this negation converts B from, let's say, minus B, so 10 from, say, 10 to minus 10. So basically, in this case, it modifies the value. And the same thing with bitwise operators. However, what makes the bitwise operators special is that the operations are done on the binary representation of the operands, which is why they are kind of like working bit by bit, and hence actually the name. It turns out that there are 6 bitwise operators in Python: a bitwise AND, OR, XOR, left shift, right shift, and finally a bitwise NOT. Now, in our exposition, through this activity, we will look at the first 5. We will not be looking at bitwise NOT. This is because, in the beginning, this could be a little bit confusing, uh, because it involves negating numbers. Now, representing negative numbers in binaries is quite an interesting discussion actually, but it could be a little bit confusing in the beginning, right? So for now, we will just focus on, let's say, A through E, which is bitwise AND, OR, XOR, left shift and right shift. And once you're more familiar with this, once you learn about things like, let's say, 2's complement, 1's complement, and so on, concepts related to, say, negative numbers, in binary, maybe you can look at bitwise NOT, and it will be fairly easy to pick up. Focusing, however, on the first 5, well, let me just classify them further into 2 categories. First, we look at, let's say, AND, OR, and XOR. The way these work is, look, I give 2 numbers. Remember, these 2 are integers. In our case, we are going to assume that these 2 are integers between 0 and 255, which means that they can be represented in 8 bits. Remember, an 8-bit number can do 0 until 2 to the power of 8 minus 1, which is 255. So I'm giving 2 numbers between 0 and 255. Some operation happens here, which is what we're going to look at later on, but I will get back another number which is also of 8 bits. So which is a number again between 0 and 255. Now, like for example, when you do arithmetic add, so I just add these numbers, I multiply, I divide, and so on. In this case, the outward appearance is the same, which means 2 inputs going in, 1 input coming out. But of course, the operation itself will depend on what we are doing, and we are going to look at that later. But important to keep in mind that inputs are integers, output is also an integer, and they have the same bit width. So 8 bits here, 8 bits here, 10 bits here, 10 bits here, and so on. On the other hand, when we look at left and right shift, well, the idea is that I give in one value, one integer, and I apply a shift value. I shift either left or right. Again, we will see what this means. We end up with a single output. Now, in case of left shift, it's possible that the output is, let's say, bigger and needs more bits compared to the input. So I give in an 8-bit input, but I come back with a 9-bit output. So those things are possible, but broadly speaking, takes a single input, a left or right shift is applied, and an integer comes out. So integer in, integer out. Of course, shift is given as a parameter, as an argument as well. Now, in the coming videos, we are going to go deeper into these, let's say, operators. And like I said, they will become very, very vivid once we start building the LED project. Now, seen in isolation, concepts like this can become very dry, but once we apply them to activities, that's when they come alive, and that is where we are headed in this project, in every project. So look at our website www.ybyte.in, because we learn Python programming by applying concepts to fun activities. Take care. Thank you so much. Bye bye.